we had a discussion about like the role
creating
of
envelopes.
envelope. Yes, there was a discussion about the envelope. What is the importance of envelope? What are the advantages and disadvantages? When to use the envelope? When it is not needed to use the envelope? And how to define the envelope in ETABS software. First thing. Second thing, we had a discussion about meshing. So what is the importance of meshing? What will happen if you are going to increase the number of meshing? What is the role of defining the meshing? What is the difference between your membrane and shell element? Okay, so that was the discussion of the last session. Thereafter, we also have seen that how to assign the staircase loading over your structure. So basically, there are three methods of considering the staircase load over your structure. So in this training program, we have covered the two critical methods. That is first one of modeling of the staircase, and second one instead of modeling of staircase, we just have calculated the loads by using the spreadsheets, and that load we try to assign over the structure. So that is what the thing. Thereafter, what other things we have seen? Is there anything missing? Hello. So almost these all kind of things we have discussed in the last session. So we are going to proceed with the later topic with all next topic. Let me show you.
That meshing, we should have done it for shear wall also, no?
Sorry?
Meshing, we should have done in shear walls also.
Yes, meshing we can do for all the elements. Like we can do for the beam, slabs, shear wall. I have shown how to do the meshing for the shear wall in the last session. Hello. I've shown that.
Yes, I know.
Okay. Now see here it is visible.
Yes, sir.
Okay. So up to the step of 14, we have completed our work. So now we have to go to analyze our structure, and we have to look at the result, and we have to proceed as usual to your medium rise structure. Okay. So just go back to your ETABS, and being this in ETABS, when you are going to work, when you are going to restart over the work, so every time you have to check the model first. Is there any modeling error or not? Let me check it. It takes some time and will show the result whether is there any modeling error or not. So if everything is okay, and after doing some setting for the analysis that we have seen in the last session, thereafter you have to perform the analysis. So the option is what? Go to analyze, and you can click over the run analysis, one option. Another option, you can click here, run analysis. So I'm going to click here, run analysis. Your software will take some time to perform the analysis, will give the result. So let the analysis to complete. So what option it is in process for the completion of analysis is on bottom left hand side. Bottom left hand side. See here it is what running. Okay. Now the analysis has been done, and we are having the deformed shape of your structure under the application of the loading. Okay. Thereafter, once the analysis gets completed, you know very well, you have to check is there any analysis error or not. So go to analyze and go to last analysis run log. Check this option and make sure that there should not be a warning message in this analysis. So yeah, if I'm trying to find out is there any warning message, so that kind of a thing is not there. Our model is also perfect. Our analysis is also perfect. So both the things are okay. You will not able to find any kind of error or warning message from here. Look at this. No warning message, no errors, nothing is there. So that's a good thing for our model, for our structure, for our work. Now close it. After that, what guidance is there? Look at your sheet. So check the model does not run into instability while analyzing by clicking on show details. If the model is unstable or is there any error, so you need to go back to check your model. Okay, so everything is okay. Clear this all. Last analysis run log is also okay. Now next we have to check torsional irregularity in your structure. Is whether your structure is torsionally regular or irregular. So what it means that try to understand. IS code recommend that Okay, we have seen that modal analysis. In the last session, we had a discussion about the modal analysis also. So what does mean by this modal analysis? As I told you, modal analysis is what the shape of your deformed structure under the application of the loading. The shape of deformed, actually the deformed shape of your structure under the application of loading. In simple, we can say that it is what mode shapes. So we have to look at our model under the deformed condition, whether it is as per the recommendation of the code or not. So like modal analysis. So how many number of modes we have considered to check out the instability of your structure? So let me show you. Load cases in modal, just go to modify. How many number of modes? Hello?
78.
78. So 78 shapes will be there. 78 shapes, 78 time periods, 78 frequency. As I told you, modal analysis is what? Finding out dynamic properties of your structure under the loading, under the seismic and wind loading. So I want to see, but all those 78 mode shapes or deformed shape of structures are not useful. The code is recommending that we have to concentrate on the first three modes. How many?
3.
First three.
Three modes you have to check, and you have to ensure that in the first mode and in the second mode there should not be presence of the torsion. Actually, for if you are going to talk about any point, like your structure is what 3D model, and every point of this model is having the 6 degree of freedom, you know very well. So if I'm taking my cursor, just go to plan, come to any particular floor. Okay, see, I'm taking my cursor here. So as I told you, for the shell element only, you will be able to see this kind of result. Number of see what I can say, degree of freedoms, results of deformation. So translational movement in X direction, translational movement in Y direction, translational movement in Z direction, and rotation X, Y, and Z. So at every point you will be able to see these. Okay, and that is what the approach with your finite element method of analysis. Remember, first thing. Second, the code is recommending that your first mode, suppose the first mode, second mode, and third mode. So this likewise, there is a 78 number of modes. So we don't need to worry about this 78. We have to just focus on the first three mode, and the code recommends that the first mode and second mode should be free from torsion. Hello. And what does mean by torsion? Movement of the structure about the z-axis. Rotation of your structure about the z-axis. So in the first mode and in the second mode, there should not be presence of rotation about this z-axis over the height. And in the third mode, if the torsion is present, that will be acceptable. It means that in the first mode, code is recommending to allow only the translational movement either in X or Y. Code in the second mode allows only the translational movement in X and Y. It is called as what? Fundamental direction. Fundamental directions X and Y in plant directions. Okay, so the code is allowing the translational movement. So if I'm going to apply the load from this direction, so complete translational movement should be there in this direction only. If I'm going to apply the load in Y direction, if I'm going to apply the load in this direction, so what? Complete translational movement should be in this direction only. So that is what applicable for the first mode and second mode. And in the third mode, if your structure is going to experience any kind of torsional movement, then it is what? Okay, acceptable. But if you are getting torsional movement in the first mode, if you are getting torsional movement in the second mode, your building is going to be rotate. So that is not acceptable in the first and second mode. It is only acceptable in the third mode. Understood or not?
Yes, sir.
Yes, sir. come back to your codal recommendation. To save the time, I have taken all the recommendation here, but the reference are given here. Where these all recommendations are given. IS 1893/2016, page number 7, table number 6. Okay, so building, how you can define that your building is torsionally regular or torsionally irregular. So for our acceptance, as per the codal recommendation, building should be torsionally regular. Irregularity should not be there. So under this situation, you can say that your building is having torsionally irregularity. Torsional irregularity. Any one of the first two modes, amongst each principal direction, sorry, not fundamental direction, that is what XY is the principal direction. You all are with me or not?
Yes, sir.
XY, sorry, okay, XY is not the fundamental direction. It is called as what? Principal directions in plan direction. Hello?
Yes, sir.
Okay. Now, having torsional movement, cleave first and second. First mode and second mode having translational movement only, and the third mode having the torsional movement. So third mode में अगर आपका torsional movement रहेगा and first and second mode is free from torsion, then that's a good. That's a good. But if your structure is having the torsional movement in the first two mode, any of the first two mode, either in the first mode and second mode, in any of these first two mode, if the torsional movement is present, at that time I will call to my structure as torsionally irregular. That is not acceptable. So first, okay. So first we will try to we will check whether our structure is torsionally regular or irregular. सबसे पहले हम लोग वो अवॉइड करने की कोशिश करेंगे, देखेंगे whether it is okay. If it is okay, then okay. If it is not okay, then what we need to do, that we will look at. You all are with me? Hello?
Yes, sir.
Yes, sir.
Okay. Come at this. Come and look at this. So like I want to see first mode and second mode. So there are different ways to check it. So first way, go to like display, go to show table, and in the analysis result, structure output and modal information, check this option. Under this modal information, here, modal load participation, no. The second one, modal participating mass ratio or mass participation ratio, sometimes we are calling it. Check this option and let's say simply okay. Once you click on this okay, like this result you will have, and try to understand how to read it and what it means. So 78 load modal cases, modal patterns will be there. 78 mode shapes will be there, and their corresponding time period. But if you would like to know the frequency, so you know that what is the formula? What is the relation between the time period and frequency? They are inversely proportional to each other. Hello? Am I right or wrong?
Yes, sir.
Okay. So remember this. Now, second thing, in the X direction, modal mass participation, actually we have to concentrate only over, we have to concentrate on translational direction X and Y for this. This is the Z direction. Translation about the Z. So see, we have not applied the load in Z direction. Have you applied the load in Z direction as the earthquake or wind? Tell me fast.
No.
It will be 0. So, so there is a 100% surety that your structure will not move in the Z direction. Adil, are you there? I think Adil is not there. So, ठीक है, Z direction में हम लोगों ने loading नहीं लगाया हुआ, तो यहाँ पर आपको कुछ नहीं मिलेगा. We don't need to worry about. Now, summation of these mode shapes. So for this, it is 100. Now addition of these 2, you will get here. Now addition of these 3, you will get here. Addition of these 4, you will get here, like that. So summation X, summation of Y. So we have to look at, UX, UI, not to Z, not needed to look at summation of X, summation of Y, translational movement in Y, and rotation about Z. It is not rotation about x is not important. Rotation about y is not important. We need to look at rotation about z and summation of rotation about z. Is that all clear? What is important? What is not important? Hello.
Yes, sir.
Clear? Now next, Vivek sir, are you getting or not?
Yes, sir, I'm there. I'm getting it.
Yes, sir.
Okay. Anirban sir, Dilip sir,
Yes, sir.
Yash, Hanuman.
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Very good. Now, okay, very interesting topic we are actually going to discuss. So you all be with me for better understanding. Okay, so now ux and uy. So clear these all first. Now see, in x direction, what is mass participation? How much mass is taking the part to resisting the load is what very minor in x direction. No need to worry about. But for the y direction, how much you are getting? 63. How much you are getting? 63. So I can conclude that by just looking over these two translational directions, I can say that my first mode is free-from torsion. Then you may ask a question how you can decide it. So if in any of the direction, in the first mode, if you are getting in any of the direction, modal mass participation more than of 60%, more than of what? 60%, then we can conclude that that mode is free from torsion. That is good. That is okay. You don't need to worry about that. Hello.
Yes, sir.
But in the second mode, okay, this is the one way. And another way how you can decide. So look at the z direction, translation about the rotation about your z direction. So here, how much percentage is there? So if this rotation value, mass participation value, if it is less than of 5%, then you can directly say that this mode is free from torsion. Hello.
Yes,
There
sir.
are two criteria how you can decide. Like, okay, if in one direction you are getting more participation value, so obviously in other direction, in that particular modal case, the value will be very, very less. So yeah, in y you are getting, x you are not getting. Okay, another thing, it is not always mandatory to have the first mode, means value should be maximum in the first mode for the x direction. It is not always necessary. Doesn't matter. Either in the first mode, if you are getting in y direction, in the second mode, obviously you will get the more value in x direction. But if you are getting in the first mode in x direction, obviously in the second mode you are getting in the second direction. So it is not always mandatory to have in x direction first, then in y direction after first. Getting or not?
Yes, sir.
पहले और दूसरे मोड में आपको कहीं पर भी मिल सकता है. पहले मोड में हो सकता है यहाँ पर y में मिला, सेकंड मोड में x में मिलेगा, ऑब्वियसली ज्यादा 48% मिल रहा है. हो सकता है इस तरीके से भी हो सकता है. फर्स्ट मोड में हम लोगों को 65 मिल जाए, सेकंड मोड में y डायरेक्शन में हम लोगों को 62 मिले. दैट इज आल्सो एक्सेप्टेबल. सो वाइस वर्सा इट विल बी. It will not always be like a condition. You should have first in x direction, then in y direction. Clear or not?
Yes, sir.
Sanjay? Hello?
मतलब सर सेकंड और थर्ड सेकंड में भी और फास्ट में वाइस वर्सा में आए.
Second, sorry?
सेकंड में भी 60 आ सकता है या फास्ट में भी 60 आ सकता है.
हाँ, दोनों में चाहिए हम लोगों को. एक्चुअली हम लोगों को तो वही चाहिए. फर्स्ट है सेकंड में दोनों में मोर देन ऑफ 60 चाहिए. यहाँ पर हम लोगों को तो मिल जा रहे हैं. दैट्स व्हाई आई एम गोइंग टू कंक्लूड दैट माय फर्स्ट मोड शेप और फर्स्ट मोड इज फ्री फ्रॉम टॉर्शन.
सेकंड मोड में तो नहीं आ रहा है ना.
सेकंड में नहीं आ रहा. अभी करेंगे ना, आते हैं, रुकिए जरा सा. हेलो.
यस सर.
हाँ रुकिए, वही तो करना है. अभी पहले मुझको एक्सप्लेन तो करने दो. हेलो.
यस सर.
ओके, इन द फर्स्ट मोड तो ये क्राइटेरिया. एंड सेकंड क्राइटेरिया इज व्हाट? इफ ट्रांसलेशनल रोटेशनल वैल्यू इज लेस देन ऑफ 5%, तो भी आप डायरेक्टली कह सकते हो कि ये मोड शेप और ये मोड नंबर दैट इज फ्री, फर्स्ट मोड इज फ्री फ्रॉम टॉर्शन. लेकिन सेकंड मोड को अगर मैं देखता हूं तो x में मिल रहा है ओके, बट इट इज ओनली व्हाट 48. मैंने क्या कहा, दैट शुड बी एटलीस्ट हेलो
60.
60. So we are getting only 48%, 48.9 or 50%, you can call it. But so here, from here also you can say that there is a torsion. In the second mode, it is not fully translational movement. There is a presence of torsion. And second, यहाँ पर देखिए कितना परसेंटेज मिल रहा है आपको? Hello.
14.55.
That is more than a 5%. So by just looking over this RZ value, you can say that this mode is having what? Torsion. So ठीक है, your first mode is free from torsion and second mode is not free from torsion. This is the way. Now, these are the time period. What time period is there? 4.43, it is what? 4.15, it is the 4.015, 1.1, something like that. So these are the fundamental time period. Got it? So in this way, you have to read this report. Close it. Now, just go to this and let me first clear this all. Thereafter, what we need to do? Okay. Another way, how you can see your mode shapes, mode. So go to this deformed shape and cases, you know, all load patterns and cases, combination, you know, what is the use of combination, you know, but this is the first time we are going to use this mode. So these are the modes. So how many number of modes? So 78 number of modes are there. Okay. So in which mode you would like to see the result? So I would like to see the result first mode, and let's just simply apply. And okay, before of that, you can click over the 3D view. Now here I'm going to say apply. Yeah, close it. So this is the mode first. Time fundamental time period is what? 4.4389. 4.4389. Okay, this is our mode shape. Now I'm going to start the animation and have a look. Is there any torsion, or is it is what free of torsion? Only translational movement is there. Just simply click on start animation. Once you click on this start animation, so it takes some time. Yes, tell me, is there any torsion in your structure, or it is what like majorly translational movement is there? Tell me.
Translational.
Translational. No, I need to go for the second mode, and we have seen that our second mode is having the torsion. So go to this, and this is the one way. Like you can check as the second mode and say apply. So second mode will come. Close it. Being in this first mode, if you want to go for the second, just click over this forward button. Just click over this. So now it is changes to second mode. Second mode 4.15. Now start the animation. Look at this here second mode and tell me whether is there presence of torsion or not. Is there presence of torsion or not?
Little.
Hello?
Yes, sir, it is true.
There is the presence of some torsion in your structure. Got it? So our objective is to avoid this torsion. As I told you, if the center of your, let me show you at the start of this project, I have shown that if the center of mass, and if the center of rigidity are going to be coincide, then we can say that your structure will be subjected to what? Will be only the translational movement will be there. But if there is a gap between your center of mass and center of rigidity or center of stiffness, center of rigidity and center of stiffness, if there is a gap between these two, so what? There will be like rotational movement. Rotational movement will be there in your structure. Try to understand. So that is the case. And center of mass is what? it is going to be dominating by your mass of that particular floor, the self weight of that particular floor. But center of rigidity is going to be influenced by the position, orientation, and size of your vertical elements. Hello.
Yes, sir.
So we can't change the center of mass of the floor majorly. Majorly, we can't change the center of mass of the structure. We have an option to play with the center of rigidity, and center of rigidity is going to be influenced by your positions of vertical element. So, like, what is the position of your vertical element? What is the size of your vertical element? What is the orientation of your vertical element? Over all these factors you have to look at, and you have to try to reduce the torsion from the mode in which the torsion is present. You are with me or not?
Yes, sir.
Clear? Okay. So अभी हम लोगों को क्या करना है? Like we have to check. We have to change the position of vertical element. We have to change the size of vertical element. We have to change the orientation of the element. Okay. So हम लोगों को change करना पड़ेगा. Now the problem is what? अभी पता ये करना. First we need to know, like from which direction, with which size of the shear wall, or for which size of the column, or in which direction our structure is lagging. That's right or wrong? पहले तो पता करना पड़ेगा क्या प्रॉब्लम क्या है, टॉर्शन क्यों आ रहा है. Am I right or wrong? Hello.
Yes, sir.
Okay. So देखिए, just go to plan, come to any particular floor. Okay, come to first basement level, apply. So let's try to understand how to see in which direction your structure is lagging with stiffness. Okay. So like go to deflected shape. I would like to see the first mode, and let me show you. And with this, draw contour, and here resultant displacement resultant, check this option, and in the first mode, and we know that first mode is what? Free from torsion almost. Say apply. This is done. Now we are at the ground level or basement level, so it is very close to your support. You all are with me?
Correct.
There is the presence of
तो
foundation.
कहाँ से है?
अच्छा, यहाँ से जाना है मोड शेप. आपको फर्स्ट मोड, आपका जितना भी 78 नंबर ऑफ मोड आपको चेक करना है. 78 नंबर. I want to check first mode. Then check this draw contour object. Then displacement result. Check this and let's say simply apply. This is done. Clear?
Sir. Okay, sir.
Okay. Abhi, this is your foundation level. So you know that at the foundation everything is fixed. Everything is fixed. 100% rigidity is there. 100% stiffness is there. So this foundation level or bottom of the structure is not it is not going anywhere. Hello, right or wrong?
Yes, sir.
Right.
100%, 110% is very stiff. Now come to the next level. This part is very close to your peak support. So obviously this will also having the stiffness, very greater stiffness. Am I right or wrong?
Right, sir.
Okay. So see here, यहाँ पर देखिए, this is what very stiff, very stiff. 100%, then 80%, then 60. What it is? 1.6, 2.4. Okay, don't consider like that. So here it is what very stiff. Now as you move over this stiff by the color, so it is what losing the stiffness, rigidity. Hello.
Yes, sir.
Okay. Now, so now I'm going to move to the next basement. Next, no movement, no effect, 100% stiffness. Move next, move next. If you are closely trying to observe closely, so here slightly movement in this direction. If you are noticing that, hello, let me show you once more. See, just come down. Now from basement to look at this. It is shifting to upside or not?
Yes, sir.
Yes, sir.
In y direction it is shifting. Okay, but see, I'm at what third level? In that direction also it is what stiff. High stiffness is there. Okay, move to the next. Yeah, stiffness is what reduced as if you are moving over the height of structure. So stiffness is going to what reduce, like not stiffness reduce, stiffness will be same. The problem is what intensity of the lateral force is going to increase. Am I right or wrong? So due to increase of that lateral force, stability of the structure is going to lose. Hello, Vivek sir.
Yes, sir.
Yeah, sir.
ओके अभी देखिए यहाँ पर फोर्थ पर आने पर कलर चेंज हो गया. कलर का मीनिंग क्या हम लोग लेंगे? द चेंज दिस लॉस ऑफ द स्टिफनेस. यहाँ पर स्टिफनेस लॉस हो रहा है. और बट एक बेटर थिंग क्या है कि यहाँ पर आपको चेंज जो मिल गया, दैट इज व्हाट 100% चेंज ऑफ स्टिफनेस. ऐसा नहीं हुआ कि इतना पार्ट आपका दिस ब्लू कलर एंड दिस इज व्हाट ऑफ दिस रेड कलर. ऐसा होता तो आपके स्ट्रक्चर में टॉर्शन आने के चांसेस थे. आर यू गेटिंग? तो यहाँ पर सेंटर ऑफ मास एंड सेंटर ऑफ रिजिडिटी इज सेम. या सो देयर इज नो चेंज ऑफ द स्टिफनेस. Here it is what it is like the case in which if you are getting for this half part as blue and this of red, so change of stiffness is there. There will be the possibility of torsion. Okay, so that is not the case. That is the good thing. That is what the good thing. Close it. Now move to the next. Again no change. Move to the next. Yeah, now here. Hello.
Sir, there is.
Slightly, see, that is what change of stiffness. Getting
Yes, sir.
this part, if you are going to look at this part is more stiff, so more stiff, so it is trying to maintain its position, but it is going to become what less stiff in comparison of this. So slightly, very minor, like this kind of movement is there, very minor, that you can't see. Hello.
Yes, sir.
Okay, so that is the case. Clear this all. Move to the next. Now here, but one thing, just come down. Another thing you can see here, that is another good thing, like this part, this color and this color, it is what adjacent colors. This orange and this what this red one and this orange one. Hello. So stiffness are very close. That's again good thing. The greater difference is not there. Red and then directly green. Hello. Then you will your structure will experience this kind of torsion. Hello.
Yes.
Okay. So that's how to read the results that I want to show you. Now move to the next. Okay, good. Slightly changes are there and complete shifting in upward direction. That's showing that what there is what okay, slightly change, then suddenly slightly change. Now colors, it is good, means stiffness are going to be less in comparison of your applied load. Okay, so जैसे जैसे आप ऊपर जाएंगे आपका lateral load बढ़ेगा और resisting capacity of the structure is going to reduce. तो उसके अकॉर्डिंग ये चेंजेस आपको दिख रहे हैं. So that's a good. तो लेकिन नीचे से ऊपर तक क्या आपने नोटिस किया होगा, योर स्ट्रक्चर इज मूविंग ट्रांसलेशनली. रोटेशनल मूवमेंट नहीं आया, टॉर्शनल मूवमेंट नहीं आया. नाउ कम टू द सेकंड मोड. सो अब मैं सिंपली फॉरवर्ड डायरेक्शन पे क्लिक करता हूं एंड फर्स्ट आई वुड लाइक टू कम एट दी स्टिल्ट और बेसमेंट वन. लेट्स अप्लाई से सेकंड मोड. लुक एट दिस, इज द फर्स्ट मोड. नाउ वी आर शिफ्टिंग टू सेकंड मोड. सो नाउ वी आर एट द सेकंड मोड. सेकंड मोड में हम लोग क्या नोटिस करेंगे? इन द सेकंड मोड योर स्ट्रक्चर इज व्हाट basement is very close to your foundation, your support, it's what having more stiffness. Move to the next. That's a good. Up to what third floor you are having the same result as that of your first. Now first mode. Move to the next. देखिए. हेलो.
Yes.
अब देखिए क्या हो रहा है. कलर चेंज तो ठीक है, क्लोज है, लेकिन पैटर्न देखिए आप. हेलो, व्हाट इज द पैटर्न? इस तरीके का पैटर्न आपको मिला था अभी तक के?
नहीं मिला.
अब देखिए क्या हो रहा है, अंडरस्टैंड कीजिएगा. This part is stiff, this part is less stiff. Okay, move to the next. देखिए, this part is stiff, this part is less stiff. अब थोड़ा थोड़ा रोटेशन इस डायरेक्शन में भी हो रहा है. If you are not you are noticing this in this direction. Now move to the next. देखिए, see, just observe this. एक ही मोड में कितने कलर्स आ जा रहे हैं आपके? हेलो, एक ही लेवल पर आपको कितने कलर्स आ जा रहे हैं? 5 कलर्स. ओके, मूव टू द नेक्स्ट. सो ये पार्ट हम देखिए कंक्लूड करिए. वन थिंग. ओके, कम बैक, कमिंग टू द बॉटम. क्या हो रहा है? आपके स्ट्रक्चर की स्टिफनेस इतने पोर्शन में, यहां पर आपका स्टिफनेस कम है. स्टिफनेस इन दिस पोर्शन इज वेरी लेस. हेलो, इसीलिए और ये पार्ट आपका बहुत स्टिफ है, यहाँ पर मूवमेंट नहीं हो रहा है, ये स्टिफ है और ये पार्ट, इसीलिए रोटेशन आपका इस डायरेक्शन में हो रहा है. यहां से हम लोग पता करेंगे कि ये पार्ट आपका लूज हो रहा है टू मेंटेन इट्स स्टिफनेस अगेंस्ट द अप्लाइड लोड. ओके, मूव टू द नेक्स्ट. कमिंग टू लाइक up to 26. See, this is my 26th floor. ये पार्ट में आपका स्टिफनेस एक्चुअली पूरा ये पार्ट अगर आप देखेंगे, पूरा ये पार्ट आपका स्टिफनेस लूज कर रहा है.
सर क्लॉकवाइज रोटेशन हो रहा है ना सर सेकंड मोड पे?
क्लॉकवाइज रोटेशन हो रहा है आपका स्ट्रक्चर में.
और सर सेकंड मोड पे है तो इसका सर वो करना पड़ेगा, इसको रोटेशन खत्म करना पड़ेगा इसका.
हाँ, सेकंड मोड में तो रोटेशन खत्म करना पड़ेगा. Your code is saying that first mode and second mode should be free from torsion.
Yes,
torsion means rotation. Okay.
Yes sir.
Who said?
सर आदिल सर.
आदिल. ओके, अभी वही इसीलिए तो चेक कर रहे हैं हम लोग अब प्रॉब्लम क्या है. सो हाउ वी कैन रिड्यूस इट, हाउ टू ओवरकम दिस प्रॉब्लम. ओके
सर, शियर वॉल डाल के.
हाँ, शियर वॉल डाल के ओरिएंटेशन. अभी देखे यहाँ पर क्या एडिशनल हम लोगों को शियर वॉल पुट करना पड़ेगा. सो एक्चुअली इट इज वेरी लाइक लॉट ऑफ ट्रायल एंड एरर्स यू नीड टू टेक. आपको बहुत ट्रायल एंड एरर करना पड़ता है, सेक्शन साइज को बढ़ाना, कम करना, ओरिएंटेशन चेंज करना, देन यू विल कम टू द फाइनल सॉल्यूशन. लेकिन इतना टाइम ट्रायल एरर हम लोग नहीं करेंगे. मैं आप लोगों को मींस बताऊंगा कि यहाँ पर हम लोगों को शियर वॉल एडिशनली लग रहा है इस डायरेक्शन में. तो इसको स्टिफ करने के लिए हम लोग क्या करेंगे, एक शियर वॉल we are trying to give one shear wall. I will provide here vertical. पहले तो यहां तक जब लोड आएगा आपका फ्रॉम दिस पोर्शन, सो उसको रिटेन मींस रिस्ट्रेन करेगा ये डायरेक्शन में. एंड यहाँ पर भी हम लोग को वीक हो रहा है, तो यहाँ पर भी एक वर्टिकल शियर वॉल दे देता हूं मैं. ये दो शियर वॉल हम लोग देकर देखते हैं क्या होता है. देन वी लुक एट द लेटर डिस्कशन. Okay, hello.
Yes sir.
Yes, sir.
Go to unlock this model, go to plan and come to any particular floor, say clear this all. Okay. Clear this all, close it. Thereafter, what we need to do, I want to delete, as I told you, we need to delete this beam on later stage. So make sure that all story option is there. Clear this. And make sure that all story option is there. Select this beam. Select this beam. Both of the beam has been deleted. Actually have to delete. So go to edit and just go to simply say like what? Okay, simply say delete. Then come to plan at the stilt level. So already at this stilt level, walls are present. So I don't need to model the wall. I will take this wall from here. I will take this wall from here. 4 shear wall. Actually, all story is there. Make it as what? 1 story. Make it as 1 story. Now this be wall and this wall. 2 walls should be there. Yeah, 2 wall. One this, one this. I will have take these shear walls from bottom to top. So go to replicate, go to edit, go to replicate. I would like to replicate this over the height. Now from this, it is what is tilt. So from stilt, from first to up to terrace, let's say simply apply. Once you done this, come to the next. So now likewise you need to come to any 24th floor. Now everywhere this shear wall is now present. Hello.
Yes, sir.
Okay.
Yes,
Now
sir.
save this model. Instead of doing anything, again go to perform or make sure that your model is correct. Check this. Let's say simply apply. This is all done.
Peer
Here-
labeling.
सर अगर बीम भी अगर कनेक्ट रखेंगे और शेयर भी डालने से उससे कोई प्रॉब्लम है क्या?
क्या कह रहे हो?
सर अगर बीम भी कनेक्ट रख रहे हैं और शेयर वॉल डाल रहे हैं
बीम और
नहीं,
शेयर वॉल
बीम कनेक्ट होगा आपका। ये बीम की बात कर रहे हो?
नहीं सर, जो अभी कॉलम के बीच में आपने डिलीट करके शेयर वॉल डाल दी वहां पे,
हाँ
तो सर बीम डिलीट ना करें और शेयर वॉल डाल दे तो कुछ इफेक्ट पड़ता है क्या सर?
बताए ना पहले, शेयर वॉल, एक्चुअली शेयर वॉल ऑल्सो आरसीसी एलिमेंट और बीम भी, तो एक ही जगह पर कैसे, क्या क्या मीनिंग होगा? दैट विल नॉट वर्क। शेयर वॉल इज आल्सो आरसीसी एलिमेंट।
यस सर।
तो
मतलब
बीम
सर,
देने की क्या जरूरत है?
बीम-
शेयर वॉल कंटिन्यू रहता है फ्रॉम बॉटम टू टॉप, तो बीच में आपको कहाँ जगह मिल रही है बीम देने की फॉर द सेम पोजीशन? क्या
मतलब
करेंगे
तो-
बीच में आप बीम डालकर?
सर नेसेसरी नहीं है ना, मतलब वो चीज।
नहीं है, मैं वही बता रहा हूँ ना। क्यों डालेंगे आप? आप क्यों डालेंगे? जैसे यहाँ पर एक बीम, एक वॉल है, शेयर वॉल। जस्ट अंडरस्टैंड, आई एम ट्राइंग टू एक्सप्लेन। ये शेयर वॉल नीचे से एक फ्लोर बीच में ये आया, ऊपर एक है। अब यहाँ पे मैं बीम डालूं, इज देयर एनी रीजन? क्यों डालेंगे बीम यहाँ पर आप? हेलो,
कॉलम का वो
शेयर वॉल है ना,
तोड़ने के
बीम तो
लिए तो
आपको, हाँ ठीक है, आप कह रहे हो कॉलम को सपोर्ट मिलेगा, राइट?
यस सर, ब्रेसिंग एक प्रकार से।
सपोर्ट, आपका बीम ज्यादा सपोर्ट देगा क्या शेयर वॉल? ये एक कॉलम आपका, ये एक कॉलम है, एक मैं बीम देता हूँ 500 डेप्थ का, और दूसरी कंडीशन में वही कॉलम है और बीच में नीचे से लेके ऊपर तक के शेयर वॉल देता हूँ, तो लैटरल स्टेबिलिटी इसकी ज्यादा मिल रही है कि ये मिल रहा है?
अच्छा, शेयर बॉल की ज्यादा मिलेगी।
शेयर वॉल ज्यादा।
शेयर वॉल नीचे से लेके ऊपर तक के आपको लैटरल सपोर्ट दे रहा है। So what's the matter to provide the what is the need actually to provide this beam? No. And with we had a discussion about it in the first I think second and third session of this structure, right?
सर तो कॉलम का वो टूटेगा कैसे? मतलब कॉलम, लॉन्ग कॉलम, शॉर्ट कॉलम का जो वो होता है क्राइटेरिया लेंथ का।
किस पर?
सर ब्रेक जैसे बीम लगाने पे कॉलम की जो इफेक्टिव लेंथ क्रैक होती है।
हाँ, तो यहाँ पर शेयर वॉल की वजह से कोई
हाँ,
इफेक्टिव, वो तो आपका कंप्लीटली लैटरल सपोर्ट मिल जा रहा है ना। वो तो
अच्छा सर।
आपका शॉर्ट कितना भी लॉन्ग होगा तो कोई फर्क नहीं पड़ता है, क्योंकि लैटरल सपोर्ट है आपको।
यस सर।
ठीक है।
और सर एक क्वेश्चन ये था
हाँ,
कि जैसे आर्किटेक्चर पर्सपेक्टिव के हिसाब से जहाँ रिक्वायरमेंट वहाँ शेयर बॉल नहीं डाल सकते, तो उसके लिए फिर कैसे टॉर्शन को काउंटर करेंगे?
हाँ, अभी ये आपने सही क्वेश्चन कहा, तो इसका आंसर मैं थोड़ा आगे देता आपको कि अभी
Yes,
तो
sir.
हम लोग वर्कआउट कर रहे हैं, दिस इज सैंपल प्रोजेक्ट एंड वेरी लाइक symmetrical
Typical project
structure
है,
it is, okay, simple geometry it is, so it is easy to like predict the behavior and correct the behavior, and actually we are practicing, so like we can do the modification anywhere. But if you are going to deal any real project, so that much command, that much rights you will not have. Are you getting? आपको
Yes,
उतना राइट नहीं होगा
sir.
कि आप कहीं पर भी शेयर वॉल पुट कर दें, कहीं पर भी कॉलम पुट कर दें। आर यू गेटिंग माय पॉइंट? सो इस केस में क्या होता है, लाइक रियल प्रोजेक्ट जब आप डील करते हो, सो एक्सपर्ट्स रिकमेंड दैट ट्राई टू अवॉइड इन वन मोड ओनली द टॉर्शन फ्रॉम वन मोड। आप दोनों मोड में कभी, मींस मोस्ट ऑफ द टाइम हम लोगों ने जितना एक्सपीरियंस किया हुआ है और जो रियलिटी है कि दोनों मोड में आप कभी भी टॉर्शन को रिलीज नहीं कर पाएंगे अगर कोई रियल प्रोजेक्ट को आप डील कर रहे हो। So experts recommend that okay, if you are succeeded to reduce the torsion from at least one mode, और one mode तो आपको करना है, वो तो ट्रायल लेना है आपको। ओके, एक मोड में आप सेटिस्फाई कर लेते हो, दैट्स मोर देन इनफ। लेकिन अभी हम लोग अकॉर्डिंग टू कोड चलना है, तो हम लोग क्या करेंगे? हेलो, यू आर विथ मी?
Yes,
Yes,
sir.
sir.
we are trying to reduce the torsion from both of the direction. तो इस तरीके से ये रहता है. आदिल, is that all okay?
सर पियर लेवल
हाँ, पियर लेवल ठीक है, पियर लेवल हम लोग कर देते हैं. एडिशनल गो टू डिफाइन, गो टू सेक्शन पावर, गो टू पियर लेवल. तो यहाँ से मैं 9 कर देता हूँ. आप 9 से ऐड वन मोर नेम एंड और एक कर देता हूँ 10 से ऐड नेम. आगे भी अगर हम लोगों को लगता है कुछ और एडिशन 11 एंड 12 से ऐड. ओके ओके कर देते हैं. मेक श्योर दैट ऑल स्टोरी. सो दिस शेयर वॉल से go to assign, go to shell, assign peer level, and what it will be 9. Let's say apply for this side. Let's say where it is what 10, apply. This is done. So 9 and 10 shear wall level has been assigned. Now I'm going to perform the analysis being this 3D model, 3D view. Now perform the analysis. Let the software to complete the analysis. Once the analysis gets completed, again we need to do the same check. Okay, this is what our deformed shape of ear structure. So that what just go to display, go to show table, show table, and with this now all the result will be changed. आपने मॉडिफिकेशन किया तो अब सारा रिजल्ट चेंज हो जाएगा. देखिए फर्स्ट मोड में आपको now x डायरेक्शन कितना मिल रहा है?
0.5 सर.
56%.
56%. अभी देखिए पहले y में मिल रहा था, अब x में मिल रहा है फर्स्ट मोड में. ओके, नो नीड टू वरी अबाउट. ना सेकंड मोड में आपको सेकंड में मिल रहा है, y में कितना 60%. सो आप देखिए सेकंड मोड आपका ओके हो गया. फर्स्ट मोड इज व्हाट हैविंग दी
थोड़ा सा रोटेशन.
Approximate 60.
ओके. तो ये और ये भी एग्जैक्टली 60 है. तो देखते हैं हम लोग मोड से. So go to display, deform the shape. Under the mode, first mode, displacement value say apply. So close it, go to plan, come to any particular floor, basement. First mode में problem आ रहा है. Okay, move top. अभी देखिए पहले हम लोगों ने पहले मूवमेंट आपका किस डायरेक्शन में था? क्लॉकवाइज. हेलो,
यस सर.
आप मूवमेंट कहाँ हो रहा है?
एंटी क्लॉकवाइज होगा सर.
Anti-clock.
सो ये पार्ट तो आपने स्टिफ कर दिया. अब ये इस साइड का पार्ट आपका लैग कर रहा है. समझ में आ रहा है आपको? देखिए ये बहुत इंपॉर्टेंट. आफ्टर डूइंग लॉट ऑफ प्रोजेक्ट्स, लॉट ऑफ ज्योमेट्रीज, यू विल कम टू द कंक्लूजन ऑफ ऑल द थिंग्स दैट आई एम शेयरिंग हियर. ओके, ये बहुत आसान नहीं होता है समझना. कहाँ पर आपको ऐड करना है, कहाँ पर चेंज करना है. हेलो,
यस सर.
ओके. सो ये मूव टू द नेक्स्ट. सो अब देखिए ये पार्ट आपका स्टिफ, इट इज नॉट मूविंग एनीवेयर. ये पार्ट आपका वीक कर रहा है इस डायरेक्शन में. मूव टू द नेक्स्ट. सो फर्स्ट मोड में ही हम लोग क्या करेंगे, आप वर्टिकल में और शेयर वॉल डाल देंगे. हम लोग यहाँ पर वर्टिकल डाल देता हूँ, यहाँ पर डाल देता हूँ. अनलॉक दिस, गो टू दिस. नाउ मेक श्योर दैट ऑल स्टोरी. फर्स्ट गो टू सिलेक्टर, go to object type, go to set display option of the floors. Apply. Now select this beam with all story option. Select this beam, go to editor and say delete. Now go to plan, come to your basement, move to the next. Yeah, still move to the next. No need to worry about. Select this. Okay, clear this. Make sure that all story is there. No, sorry, one story should be one, and here it should be what? This side, I think. Wait, yeah, this side has one. Now go to editor, edit, go to replicate it. Now story, I would like to take these all from first to up to terrace. Let's say apply, close it. Okay, now move to the next. Everywhere it is present, show all story. Select this, go to assign, go to shell, go to peer level, and it is what? 11 shear wall 11. Select this, shear wall 12, say apply. This is done. Now save this, perform the analysis. Take the 3D view, go to set display option, floors also, apply. Now start the analysis and let the analysis to complete. Once the analysis gets completed, what next will be try to understand.
सर जब तक एनालिसिस हो रहा है एक क्वेश्चन था
Sorry?
सर जब तक एनालिसिस हो रहा था एक क्वेश्चन था
हाँ कौन?
सर आदिल
हाँ बोलिए।
तो सर जो लेटरल डिफॉर्मेशन अपन देख रहे हैं स्टिफनेस का
हाँ
इसका चेक HY 250 से चेक करते हैं ना सर
हाँ वो भी आगे आएगा, बताता हूँ।
ठीक है सर
ये अलग है। टॉर्शनल इरेगुलरिटी चेक इज द डिफरेंट थिंग। वो
Yes.
मैक्सिमम लैटरल डिफॉर्मेशन लिमिट है आपका। हेलो।
हाँ सर वो पढ़ा था मैंने
हाँ वो अभी आएगा आगे, सब आगे के पार्ट्स है।
ठीक है सर
Now with this go to plan, come to any particular floor or especially at the basement. Now see, I would like to see the modal result. Go to this. I would like to mode first, or otherwise go to display, go to show table, and now with all that selection, I am having the result as now first mode 61%, second mode is having what?
61 sir
61.
Equal.
Now
Equal.
both first and second mode is free from torsion or not?
yes sir free from torsion
Look at this RZ value. This is also less than of what?
5.
5%. That is also good. So in this way, in the third mode, what you are getting? Point not. Okay, so like here very large torsion is there, 60% torsion value. So okay, that's what acceptable. Hello.
Yes, sir.
Okay, so that is what the case, how you can eliminate the torsion from your first mode and second mode. Got it? Now close it. Okay, I go to 3D view, and now I would like to see the deformation in the mode, first mode, apply, close it, just say add one more window here, and just go to, in this window, I would like to see the mode shape 2, second mode, apply. Now add one more window. Now second, just go to in this, I will have to see the third mode. Apply this. Alright. Now in the first, say start animation. Look at the result. First, second, third. Your first mode is having the torsional movement in this direction. Your third mode is having the torsional movement in this direction, translational movement, and your third mode is what? Hello.
Torsional.
Torsional.
Okay, your third mode is having what? Rotation. So that is what the case. How you can understand whether your mode, first mode and second mode is free from torsion or not. Got it? Now with this say stop mouse and say stop animation. Here also say stop animation, for here also say stop animation. Now close this window, close this window. Now, let's say come to undeformed shape, come to plan at any particular floor. This is all done. Now close it. Come back to your sheet. So your first mode and second mode, that is what? Okay. Natural period. So fundamental time period is what? Go to display, go to show table, the time period. So another criteria, the time period should decrease from first to all the later modes. So first mode should have the maximum fundamental time period. Second mode will be the lower value. Third mode will be lower value. Likewise, your time period is going to decrease. Obviously, the time period is what? Fundamental time period. The time required to complete one oscillation, we are going to call it as what? Time period for the structure. So suppose I'm going to consider any structure which is suppose the cantilever. So under the application of the loading, your structure is going to be deformed what? Like this, coming back and then coming like this, now coming back. So in the first case, when the sudden hit to the structure is there, so initially the momentum in your structure will be very large, so that your structure is going to be deformed to a greater extent, then coming back, then coming to a greater extent, then coming back. So time required to complete one oscillation will be more. But as the time is changing over the passing of the time, this vibration is going to reduce due to damping property of the structure. Yesterday we had a discussion about it. So धीरे धीरे क्या होगा, ये कम होगा, फिर धीरे से क्या होगा, ये कम होगा, फिर क्या होगा, कम होगा, and at the end it is going to come into the static condition. Is that all okay?
Yes.
Yes, sir.
इस तरीके से फर्स्ट मोड में आपका टाइम पीरियड ज्यादा होगा, फिर कम होगा, फिर कम होगा, फिर कम होगा. Likewise, it will be decreasing. Okay, so यहाँ पर फर्स्ट मोड में आपको चेक करना है for the analysis to be correct कि फर्स्ट मोड सबसे ज्यादा चाहिए, फिर सेकंड मोड में कम होना चाहिए. किसी एनालिसिस में आपको फर्स्ट मोड में कम मिल रहा है, सेकंड मोड में ज्यादा मिल रहा है, सो एक्चुअली योर एनालिसिस इज रॉन्ग. समथिंग इज रॉन्ग विद योर मॉडल एनालिसिस. गॉट इट? सो आपको ये चेक करना है. तो यहाँ पर हमारे केस में क्या हो रहा है? हेलो,
ऊपर से नीचे घट रहा है,
कम हो रहा है ना. सो दैट इज व्हाट ओके. हियर इट इज व्हाट natural period corresponding the fundamental torsional mode of oscillation is more than those. So क्या यहाँ पर बता रहा है कि अगर थर्ड मोड में आपको ज्यादा टाइम पीरियड मिल जा रहा है इन कंपैरिजन ऑफ फर्स्ट टू मोड, ऑब्वियसली योर स्ट्रक्चर विल बी टॉर्शनली रेगुलर और इरेगुलर. इरेगुलर. ओके. द फर्स्ट थ्री मोड्स कंट्रीब्यूट्स लेस देन 65%. अभी देखिए ये बहुत क्रिटिकल है. अब क्या क्राइटेरिया मिल रहा है कि पहले तीन मोड्स का आपको सम करना है, समीशन ऑफ एक्स और या फिर समीशन ऑफ वाई. समीशन शुड नॉट बी लेस देन ऑफ व्हाट?
65%.
65%. अगर ये 65% से कम मिलता है आपको, सो योर स्ट्रक्चर इज व्हाट? हैविंग द टॉर्शनल इरेगुलरिटी. चेकिंग आवर मॉडल. सो ये भी बहुत क्रिटिकल केस है जिसको सेटिस्फाई करना पड़ता है हम लोग का, मींस करना बहुत क्रिटिकल है. तो देखते हैं हम लोग. समीशन इन द फर्स्ट मोड, एक्चुअल जो भी रहेगा वही रहेगा. एडिशन ऑफ द सेकंड, ये दोनों ऐड करके आपको एक्स में ये मिलेगा. ये तीनों ऐड करके आपको क्या मिल रहा है?
62%.
61, ऑलमोस्ट 62%. तो थोड़ा सा यहाँ पर हम लोग लैग कर रहे हैं. अगर इसको भी सेटिस्फाई करना है तो फिर अगेन आपको बहुत ज्यादा वेरिएशन करना होगा. ओके, बट वी आर गोइंग टू से इट इज ओके. हेलो, ओके. अगर आपको इसको सेटिस्फाई करना है देन यू हैव टू प्ले विद द साइजेस ऑफ द एलिमेंट्स. बीम के साइज में, स्लैब के साइज में, कॉलम के साइज में, शियर वॉल के साइजेस में आपको बहुत चेंजेस वगैरह ट्रायल एंड एरर करना पड़ेगा. देन यू विल कम टू सम वेरी क्लोजर वैल्यू ऑफ 65. हेलो.
Yes, sir.
ओके,
सर लेकिन ये हेलो
बताएं.
सर, यू सेड ना कि मोड 2 में अगर 60% से कम होगा तो भी चलेगा करके टॉर्शनल इरेगुलरिटी.
क्या कह रहे हो सर?
मोड 2 में, मोड 1 में हम लोग ने चेक किया, इट इज ऑलमोस्ट 60%, बराबर ना.
हाँ.
मोड 2 में अगर लेस देन 60% है तो भी चलेगा, ऐसा आपने बोला था ना.
हाँ, प्रैक्टिकली जब आप एक रियल प्रोजेक्ट को
Yes,
डील करने
exactly.
जाएंगे तो वहां पर
हाँ.
आपको इतना कमांड नहीं, इतना राइट नहीं होगा कि आप कहीं पर भी शियर वॉल डाल दें, कहीं से भी निकाल दें. आपको तो पता है. ओके, आर्किटेक्चर ने जो पोजीशन दे दिया तो हम लोग को बस ऑलमोस्ट वो 100% फाइनलाइजेशन होता है, राइट.
फिक्स
कुछ
होता है
थोड़ा
वो,
बहुत चेंजेस हो
करेक्ट
गए तो हो गए, अदरवाइज नहीं होंगे, राइट,
करेक्ट करेक्ट।
है ना। तो उसमें हम लोगों के पास ज्यादा चांस नहीं होता है कि आप कहीं पर भी शेयर वॉल को कम कर दे, ज्यादा कर दे, पोजीशन चेंज कर दे, इवन ओरिएंटेशन में भी। तो उस केस में लाइक कहीं पर आपको बहुत ज्यादा टॉर्शनल इरेगुलरिटी मिल रहा है, टॉर्शन मिल रहा है, तो फिर आप कंसल्ट करके मींस आर्किटेक्चर को कन्विंस करना पड़ेगा, तो आप वैसे डील कर सकते हो। लेकिन उसमें भी आप सिर्फ एक ही मोड में कर पाएंगे, दोनों मोड में करना बहुत डिफिकल्ट होता है। अगर कर लेते हो दैट्स वेल एंड गुड,
बराबर है,
आप अगर कर लेते हो तो बहुत अच्छी बात है। क्लियर?
यस
बराबर, यस सर।
ओके ना। लेकिन अभी हम लोग जो क्राइटेरिया देख रहे हैं विवेक सर, वो देख रहे हैं समीशन का। तो कोड हम लोग क्या कह रहे हैं कि अलग
यस
क्राइटेरिया,
आई नो 65%, यस।
तो फर्स्ट 3 मोड का समेशन करना है, और उसका समेशन करके हम लोग समेशन, ये समेशन ही है। आप कहेंगे कि मैं ये तीनों को ऐड करूंगा, ये नहीं। फर्स्ट देन एडिशन ऑफ फर्स्ट with this second we are getting this value, with this second and this we are getting this value, so finally हम लोग क्या मिल गया 61। so ठीक है, वेरी क्लोज टू 65 हम लोग कहेंगे कि ओके है। अगर इसको भी सेटिस्फाई करना है तो मैंने आपको बता दिया क्या करना पड़ेगा, बट वी आर विलिंग टू गो विद दिस वैल्यू। ओके नाउ, तो ये भी है। Second requirement is what? Okay. Third, the first 3 modes contribute. Okay. The fundamental lateral natural period, time period of the building in 2 principal plane direction are closer to each other by 10% of the larger value. इसका क्या मीनिंग है? हेलो, देखिए,
T1 and T2 should not differ by more than 10%.
they should be differ by more than 10% if you would like to have your structure is torsionally regular. अगर वो डिफर नहीं हो रहा है 10% से ज्यादा, सो आपका स्ट्रक्चर क्या है?
रेगुलर इरेगुलर।
मीन्स क्या है? T1 एंड T2 के बीच में डिफरेंस जो होना चाहिए, कितना होना चाहिए? दैट शुड बी मोर देन ऑफ 10% एट लीस्ट। चेक करते हैं ऑफ द ग्रेटर वैल्यू, of the greater value. So very simple, come back to your ETABS. यहाँ पर पहला टाइम पीरियड हम लोगों को मिला हुआ है 3.814। यहाँ पर भी बहुत डिफिकल्ट होता है इसको भी सेटिस्फाई करना, बट वी विल सी 3.814। इसका 90% कितना आएगा? देखिए 0.9, 3.814 multiplied by 0.9, give me answer.
3.43.
Sorry,
3.43.
3.43।
43.
ठीक है, so your second time period should be less than of this, but हम लोगों को कितना मिल रहा है?
It's more.
So the difference is what? 3.814 minus 3.721. Give me the answer.
0.093.
0.093 divided by greater value 3.814 multiplied by 100. Give me the answer. What is the difference by percentage?
2.43.
Sorry,
2.43.
2.43%. Only 2.5% difference is there. So here also we are lagging. इसके अगर आप ये सेटिस्फाई कर लेंगे ऑटोमेटिकली ये भी सेटिस्फाई हो जाएगा। क्लियर है? तो इसके लिए भी आपको लाइक ओरिएंटेशन के साथ, साइजेस के साथ, ओके, पोजीशनिंग के साथ प्ले करना होगा। देन यू विल सक्सीडेड टू लाइक get this recommendation to be satisfied in your structure. Hello, close it. Coming back. So this is all the first case. Check this. Now come to next. इसी का रिवर्स सारा स्टेटमेंट यहाँ पर है। इन सिस्मिक जोन फर्स्ट एंड सेकंड and third, the first 3 modes together contribute 65%. Same thing in seismic zone 4 and 5. In addition to the first, the fundamental natural period, ये भी सेम केस है। Number of modes to be selected. Okay, there is another thing. अच्छा, यहाँ पर हम लोग कितने मोड्स कंसिडर करना है? हम लोगों ने तो 78 मोड्स ले लिए हैं। So code is recommending that the number of modes to be selected such that at least 90% of total seismic mass should be participated along the considered direction of loading. So at least 90% mass participation should be there. तो हम लोग फर्स्ट मोड में अगर देखेंगे तो यहाँ पे 61 था एक डायरेक्शन में, फिर समेशन, एक्चुअली वी हैव टू लुक एट द समेशन इन एक्स डायरेक्शन, 61 61 61 78 78 78 so 90, so 90% mass participation. कितने नंबर पर मिल रहा है आपको ये?
31.
31. So here it is 31 number of modes are enough to look at the behavior of structure. So 31 it is okay. For y direction 90. For y direction you have to increase the number. So y direction के लिए हम लोगों को लग रहा है 34. So we will consider the x as a 34 also. Okay. So we have to look only the x and y direction. So it is what 92 and 91. So 34 it is more than enough. तो हम लोग क्या करेंगे, नंबर ऑफ मोड्स कम कर देंगे 34. तो जनरल रिकमेंडेशन मैंने आपको दिया था, that should be what 3 times. So 3 times number of floors initially. लेकिन number of modes आपको कितना कंसीडर करना है? Code is recommending that 90% mass participation should be there. Hello, in summation. Okay, so that will be the thing. The modes having the frequency, natural frequency greater than 33 hertz or modes of natural time period 0.0303 should not be considered. क्या कह रहा है हम लोगों को? The time period whose the particular mode whose time period is less than 0.0303, इससे टाइम पीरियड कम रहेगा तो वो भी मोड को आप निग्लेक्ट कर सकते हो. तो मैं जाता हूं स्ट्रक्चर में 34 पर देखते हैं हम लोग क्या मिलता है. गो टू डिस्प्ले, गो टू शो टेबल. लुक एट द 34 पर टाइम पीरियड इज हाउ मच?
0.11.
हम लोगों को क्या बोला हुआ है?
0.03.
0.03. सो लाइक इफ द टाइम, ठीक है, इसके आगे का भी आप कंसीडर कर सकते हो, लेकिन अगर 0.03 से भी कम टाइम पीरियड है तो फिर उसको तो कंसीडर करने की जरूरत ही नहीं है आपको. 0.03. अब इसके बाद आप इसकी जरूरत नहीं है. सो 64 के बाद तो एनी हाउ ये आपको नहीं करने की जरूरत है. और एक्चुअली ओवरऑल हम लोग इतने मोड की जरूरत नहीं होती है. We only have to concentrate on the first, second, and third mode. Understood? Hello.
Yes, sir.
Yes.
Yeah. Go to like this. So this is what all the criteria. Now next we have to check what we have to scale the base shear value. So you know that under the action of lateral force, the maximum induced inertia force is going to be generated at the base of your structure, and that base shear value is going to be distributed over the height of structure. Those who have completed the shared video for the base shear load calculation, they can understand better. So अब क्या है, बेस shear का हम लोगों को मैच करना है. So क्या है, what is the need to scale the value for the base shear? So look at your IS code, IS 1893/2016. So the code is recommending that, yeah, see, okay, but before of that let me show you how to see the base shear. So go to display, being your model to be being as analyzed. So go to display, here story response plot, check this option, and here check this, and story shear, check this story shear, and here under what I would like to see in x direction, earthquake in x direction.
X direction.
Positive, let's consider x direction, and story shear at the base, how much value it is? Hello.
Minus 5097.
Minus
5097.
okay, for x direction, earthquake x direction, minus, don't need to consider minus sign, okay, forget that. Just look at the value
5097.
5097, okay. This is what static base shear. Now dynamic base shear is what? Response spectrum in x direction. So I need to see that. Go to see, change it to what? It's, yeah, response spectrum in positive x direction. What you are getting? 2221. How much?
2221.
2221. Okay. This is for x direction static value. This is what the dynamic value. Now come to see for y direction also. Okay, first look at y. 2471 response spectrum ry
2471. 2471.
and ey will be what?
EQ.
EQY. What you are getting? 3949, right?
3949. 3950.
39. No, exact take.
3949.
3949. Got it? So this is the value we are getting. Now these are the base shear values. It is in kilonewton. Okay. Now forget this all. Come to your code. This is my code. What code is saying? Yeah, that's a problem. Okay. See, what code is saying? When, see, the dynamic analysis may be performed by either the time history and response spectrum. When either of the method is used, whatever the method, either you are going to use response spectrum or time history. When either of the method is used, the design base shear VB estimated shall not be less than the design base shear VB dash. Dekhiye, very interesting. What code is saying that whatever the dynamic method you are going to choose for the analysis, and you are getting the base shear value, so it is VB denoted by, so VB is your dynamic value. Estimated shall not be, actually dynamic value should not be less than the design base shear VB. That is what? VB dash it is actually. Let me, VB dash, are you getting?
Yes, sir.
VB dash, it is static value. It is what? VB is your dynamic. So क्या कह रहा है आपको? Your dynamic value should not be less than of your static value. But if it is like that, so when VB, your dynamic value is less than of your static value, the force response quantities, for example, member stresses, story base shear and all, shall be multiplied by what?
VB static by VB dynamic.
Static by your dynamic value. यहां से हम लोगों को स्केल फैक्टर मिलेगा. क्या मिलेगा?
Scale factor.
So ये स्केल फैक्टर हम लोगों को कोड रिकमेंड कर रहे हैं. Most of the students are asking why we are doing it. So ये आपका रीजन, आपका कोड आपको रिकमेंड कर रहा है. तो अब हम लोग हमारी वैल्यूज देखेंगे. दैट इज द केस और नॉट. देखिए हम लोग डायनामिक क्या है, स्टैटिक एंड डायनामिक. तो डायनामिक आपको कम मिल रहा है या ज्यादा मिल रहा है?
कम मिल रहा है. डायनामिक कम है.
तो स्केल करना पड़ेगा कि नहीं करना पड़ेगा?
करना पड़ेगा.
ठीक है. सो स्टैटिक बाय डायनामिक वैल्यू. सो एक्स डायरेक्शन के लिए अब कैलकुलेशन हम लोगों को करना है. फॉर एक्स डायरेक्शन स्टैटिक इज व्हाट?
2221. अच्छा 5097
divided by
2221.
give me the answer for this for x direction. हेलो
2.29.
2.29
29.
और क्या इसके आगे? व्हाट एल्स? गिव मी अप टू 4 डिजिट.
2.2949.
49. Okay. 2.2949. For y direction, it is what? 3949 divided by 2471. Give me the answer.
1.5981.
1.5981.
81.
Got it? 1.5981. Getting? So this is what, remember this. Now close it. Okay, close it. This window. Now unlock your model. Go to define. Go to load cases. Take it here. Now response spectrum. Go to modify, show this result. Now here, scale factor. So whatever the values they are related to be, multiply this value. हम लोगों को क्या चाहिए? Static and dynamic हम लोगों को same करना है. Objective is what? We have to match the static and dynamic. Multiply this value with the x direction. U1 is the x. What is the scale factor?
2.49. 2.49.
2.2949.
49. Right? Just say enter. Done. Say okay. That's it. For y direction, go to modify this and take it here for now. Multiply this with what?
1.5981.
1.5981. Say enter and then say okay. This is done. Let's say okay finally. And now clear this all. Now perform the with the 3D model, perform the analysis and let the analysis to complete. This is called as scaling of base shear. Okay, once the analysis gets completed, now go to display, go to story response plots, and I would like to see the display story shear, and under this dead load pattern, I would like to see for earthquake in positive x. So what? 5097. Likewise, I would like to see 5097. Remember 5097 for response spectrum in x direction. 5097 exactly match is there or not?
Yes, sir.
With the matching of base shear. For z direct for y direction. 3949.6. 3949.3. So it is okay. Understood or not?
Yes, sir.
So this is the way how to scale the base shear value. So it is all done. Static by dynamic. Unlock the model. This is also how we have completed. Now next, check the response spectrum is correctly scaled. That also we have checked. Now check the model analysis for okay model. Overall deflection. Now overall deflection. Maximum deformation under the lateral loads. आपका maximum lateral deformation कितना होता है? Under X means under earthquake loading and under the wind loading. Okay, so IS code recommends that. Let me show you. Here, a lateral sway, maximum lateral deformation at the top of your structure. Under the transient wind load, the lateral sway at the top of the structure should not exceed total height of the structure above the ground divided by 500. Hello.
Yes.
Under the wind loading, under the earthquake loading, it is H by 250. Under the earthquake loading, the total height divided by 250, and under the wind loading, it is total height divided by 500. So our structure height is what? 93.85, right or wrong?
Right, sir.
93.85. So 93.85 multiplied by 10 raised to 3 in mm divided by first under the earthquake. Under the earthquake it is what? 250. Give me answer. How much it will be?
375.4.
37. 5.4
Four.
mm. This is the maximum lateral deformation, lateral deflection, deformation, displacement is allowed. If your structure is going to experience settlement or deformation more than of this value, means we need to look at some measure for that to reduce it. And this is for earthquake. And for wind, it is what? H by 5.
Half
and
of it.
half of it. Give me the answer for this.
750.
7. Sorry.
750.
Half.
375.4
Oh,
by
yeah,
2.
sorry. 3.
187.70. 187.7. 187.7.
7. This much mm. This is what earthquake, more allowance are there, and in wind there is a less allowance for the deformation. So clear this all, close it, come back to your ETABS and go to deformation, lateral settlement, and it is what under the earthquake for the 2. Let's simply apply.
Displacement.
Displacement in x direction, apply this. So how much maximum you are getting?
163.
163. Which is less
And your
than
allowance is how much? 3.
375.
So you are safe or unsafe?
Safe.
Now for the wind positive, yeah, wind x direction, let's say apply this. How much you are getting?
15.
No, something wrong.
X. Y. Displacement Y, sir. Y, yes.
No, something is wrong.
Oh, your contour for
Wait, sir. Yes.
the middle part.
Q plus X.
Why?
Acha, Y.
Okay, for y. No, why I'm not getting the direction?
Load X.
Yeah, right. Actually, the problem is what? See, okay. Why we are not getting the settlement? Can you guess? Sorry.
No, sir.
Just go to define, go to load pattern. हम लोगों ने लोडिंग ही असाइन किया हुआ है ना. मैंने आपको कहा था मैं इसको करेक्ट करूंगा, बट मैं तीन ही लेवल पर आपका लोडिंग है. हेलो.
We did not fill up the blanks.
गेटिंग? हेलो.
Yes.
तो ये जब
Yes.
आप करेंगे तो एक्चुअली ये भी सेफ होता है. आपको यहाँ पर ऑलमोस्ट कुछ 50-67 mm डिफॉर्मेशन मिलेगा आपको, राइट? हेलो.
Right.
That will be safe or unsafe?
Safe.
Safe. So इस तरीके से आपको lateral deformation चेक करना है. That is the case. Okay. Model is all done. Deflection also has been checked. Okay. Now next, view and revise preferences for concrete and okay. Now we have to move for the design. Undeformed shape. Now I would like to design first all the column. I just show you whether the column they are passing the design check or not, whether the beams passing the design check or not, and shear wall. So go to selector, go to object type, select all the columns. Okay, first select all the structure, go to this design, go to concrete, view revise preferences. Here all the things will be as it is. We don't need to do anything. Okay. Then option, go to design, go to concrete, and here view revise override, check this option. This should be ductile. Rest of all the things will be as it is. If you want to do the modification effective length factor, so make it as 1.2. If you want to do, otherwise you can keep it as it is. Sorry. I'm doing a mistake because I have checked all the entire structure right now. Okay, not only the columns. Hello.
Yes, sir.
That is applicable for only the column. So yeah, it is what right. So it is done. Clear this. Go to selector, object type, select all the columns, then go to assign, go to go to design, go to concrete, go to view revise preference, overrides, and now change it to what? 1.2, 1.2, 1.2, 1.2. This is done. Let's say okay. Then thereafter, with all of this, first I would like to design the columns. So go to select, go to object type, and select all the columns. Being these all columns selected, go to design, go to concrete, go to select design load combination from 101 to 125. So I think whatever the numbers is present here, I will take that also. Sorry. Yeah, 125. Take it down.
125, right.
125. Let's say okay. Now go to design, or you can simply say start design from here. Where it is? No, go to design, go to concrete, start design check.
Start design on the middle.
Yeah, shift plus F6, yes.
It is going to perform the design for all the elements.
Vertical elements.
Vertical elements, yes. So now go to display, go to design, go to concrete, verify. All members are passing the design check. So 700 actually it is showing for beam also. Hello. Actually हम लोगों ने beam को डिजाइन नहीं किया, beam का ये शो कर रहा है आपको. Say yes. मैंने सारे failed दे दिया. Right click show selected object. कहीं पर कॉलम दिख रहा है आपको?
नहीं सर.
Means all column have passed the design check, right?
Yes.
Now go to select, go to object type, select all the beams. I have selected all the beams. Go to design, go to concrete, combination. Now instead of all these, take it down left hand side. Now what?
Factor the
201 to
225.
225. Take it down this side. Let's say okay. Perform the design again. Start design check. Now at this time only the beam is will be under design, as you can see.
Yes.
Okay. Now at this time go to design, go to concrete, verify all member pass the design. Now see, beam and column, frame element was passing the design check, right? Hello.
Right, sir. Right.
Now then
Now here wall.
yes, go to select, go to object type, select all the walls, select this all, go to design, go to concrete, sorry, go to shear wall design, view revise preferences. Actually we have to change the grade 500, and here it should be what? 500. Clear? Why?
Yeah.
Here it is needed to define the grade, because at the time of defining the shell element, shear wall element, there at that time there is no option to define the grade of steel. Getting?
Yes. Yes.
हाँ, यहाँ पर आपको इसको करेक्ट करना है. Let's say okay, this is done. Again go to design, go to shear wall. This is all done. Now start design check. The design has been done. Go to display design, go to shear wall, like verify wall design check. And it's a design section match for all area object. Hello.
Yes, sir.
Okay. So this is all about how to deal with this high-rise structure. Hello.
yes, sir.
So this is all about this complete training program. Okay. So like if you want to ask anything, so that you can ask.